All right, so here we're going to be talking about increasing and decreasing parts of the graph and coming up with equations from the from polynomial graphs and actually graphing polynomial graphs from the equations. All right, so this first one, it says, what is true about the graph on the interval from x equals e to x equals infinity? So that's going to be right here. E to infinity is this part here. All right. So basically, they want to know if it's positive or negative, and then if it's increasing or decreasing. So to determine if it's positive or negative, if it is above the x-axis, we are positive. If it is below the x-axis, we are negative. Okay. So this one is below the x-axis, so we are negative. So it's going to be one of these two options. And then kind of the way to imagine it is, imagine if you're reading a book, right? You go from left to right. As you go from left to right, is the function going up or down? It's going down. So this one's going to be negative and decreasing. All right. Now, the other options, I know I didn't put them in here, but just to save space, I was like, that takes up a lot of paper. So you have the same options for the rest of these on the page. Is it positive and increasing, negative and increasing, negative and decreasing, and so on. So the next one, they want us to look at point B to C. So that's going to be from here to here, okay? So again, to figure out if it's positive or negative, if it is above the x-axis, we're positive. If it's below, we're negative. We can see that this one is negative. And then imagine if we're reading a book, we're going from left to right. Are we going up or down? We're going up, so it's going to be negative and increasing. All right. Then, next example, E to F. So we're going from here to here, all right? We can see that, well, first we can determine if it's positive or negative. If it's positive, it's above the x-axis. It's negative, it's below. E to F is positive. And then we look left to right. We are going up, so it's going to be increasing. All right. Next, they want us to actually write the equations of these polynomials. So you should already feel pretty comfortable with identifying the roots from looking at the graph. The only thing that really is going to be new here is determining the a value, which you've done with quadratics before. In Math 2, there were problems where they gave you the vertex and a point on the quadratic, and you had to go find the a value. Essentially, that's what we're going to do here. It's going to be like a, and then we're going to have, obviously it depends on how many roots we have, but we plug in all of our roots here, and then we're going to use the y-intercept to find our a value. All right, so let's take a look here. We can see that this guy goes through -5, and it bounces there, right? So that's a multiplicity there. That's going to have a multiplicity of 2. It also goes through 8, all right? So we know that we're going to have x plus 5 squared, all right? And we're going to have x minus 8. Now, the only thing we don't know is our a value. Now, from looking at this, we should be able to tell just by looking at it if our a value is going to be positive or negative. So by looking at this graph, I can tell that this is going to be an odd degree, which that's what we got here. We have a degree 3. And it's going to be negative, the coefficient, all right? Because if you look at the behavior, right? I'll scroll back up here. If we look at the end behavior of this graph, it's following this, right? Where as x goes to negative infinity, the function goes to positive infinity. As x goes to positive infinity, the function goes to negative infinity. So that's just kind of a quick way to check your answer. That's not really going to help you find your answer, but it's kind of nice to know if your a is going to be positive or negative by looking at the graph. Now what we're going to do is we are going to use our y-intercept here. Technically, you could use any point other than the roots to find the a value. But on these graphs, it's going to be particularly easier to use the y-intercept. So our y-intercept here is 0, 80. So what we're going to go do is we're going to take a 0 and go plug it in for x. And then we're going to take my 80 and go plug it in for y. All right. So what we're going to do 80 equals a times, and we get 0 plus 5 squared, 0 minus 8. All right, so what we can do is go plug all of this stuff into our calculator, the stuff that's attached to the a. So 0 plus 5 is 5, so we get 5 squared times, and then negative 8. All right, so I got negative 200. So that means that I get 80 equals, and this stuff that you plug into your calculator is times a, so you could just slap it in front of the a. We get negative 200 times a. All right, we divide by negative 200. I'm going to do 80, whoops, divided by negative 200, and I get negative 2/5. So that means that my a value is negative 2/5. So my final answer here is going to be y equals, and then my a value, which is negative 2/5. And then I've got my roots that I found, which is x plus 5 squared, x minus 8. This is my equation. And I'm going to go ahead and show you that we're right. We're going to go graph it on Desmos. So if I go and graph this, and I do, oh, I hate when it does this, go away. Negative 2/5 times x plus 5 squared times x minus 8. All right, let's see. We can see that we did kind of, I guess it zoomed out so much. Let's see, this graph went up to 200, so I can change the settings here. We want our y-axis to go up to 200 and our x-axis to go down to negative 200. There we go. All right, so we can see here that we do have, that we were able to come up with the graph that we were given here, right? We have our y-intercept of 80. We have a bounce point at negative 5, and we have a regular root there at 8. All right, so awesome job. All right, let's try another one. So looking at this one, we are going to have a bounce point at negative 5, so it's going to be x plus 5 squared. And we have a bounce point at 2, so it's going to be x minus 2 squared. All right, those are the only two roots we were given. And looking at this, right, it's going to be an even degree, and it's going to be a negative leading coefficient. How do I know that? Well, both of the end behaviors are going down to negative infinity, which indicates that we're going to have an even degree, which is checking out because we got squared and squared, which is going to be a degree 4, and it's going down. All right, so now we just need to go ahead and find our a value. So again, we're going to use our y-intercept that they give us. Sorry, that's my dishwasher. I don't know if you can hear the beeping. So our y-intercept is 0, negative 100. So we're going to take the 0 and go plug it in here. And then we're going to take the negative 100 and go plug it in for the y value. So we have negative 100 equals a times 0 plus 5 squared times 0 minus 2 squared. And I can go to my calculator. And obviously, if you can do this math in your head, that's perfectly fine too. I'm just doing it all in my calculator so that you guys can see how to plug it in if you're someone that likes to plug it in. So when I do that, I get 100. So I get negative 100 equals, and then remember how I said this, when you plug this in, that becomes the coefficient on a. So we get 100a. We have to divide by 100, and we get that a is negative 1. So our answer here is going to be y equals, and then our a value of negative 1. You could just do negative, and then x plus 5 squared, x minus 2 squared. And again, I'll go ahead and show you real quick so that we could check. Negative x plus 5 squared, x minus 2 squared. And you can see here, again, the reason the shape looks a little bit different is just because of the scale on the x and the y-axis. But you can see that our features are here, right? We want to go through negative 5, have a bounce point at 2, and have a y-intercept of negative 100. So we did an awesome job. All right, so now we're going to go ahead and try some graphing. So when you're graphing, I want you to have an idea of the general shape of the graph before you graph it. So I want you to think about if it's an even or odd, and if it's positive or negative leading coefficient. All right. And then obviously you want, so those are the two things you think about. And the two things that you really need to find are going to be the roots and your y-intercept. Okay. Once you have all this information, then you can go ahead and graph it. So if we look here, we've got a root at -4 with a, I don't know why I put a 5, at -4 with a multiplicity of 2. So we know it's going to bounce there. All right. And we also have a root at 1. So let's go mark that. We're going to mark -4 and we're going to mark 1. All right. Then we want to find our y-intercept. So we're going to go plug in 0 for x. So I'm going to do, I guess I could do it down here. 0 plus 4 squared times 0 minus 1, which is going to give us, what, 16 times -1, which gives us -16. So our y-intercept is going to be 0, -16. All right, so I also want to mark that. That's going to be right here. All right, now, looking at this, we have a power of 2 here and a power of 1 here. So this one is a degree 3, okay? 2 plus 1 is 3. And we have a positive leading coefficient, all right? So it's an odd degree and a positive leading coefficient. So that means that no matter what happens in the middle here, the end behavior is going to look like this, right? On the left-hand side, it's going to go down. On the right-hand side, it's going to go up, okay? We know that from this chart up here. All right, if we have a positive leading coefficient, which in this case it was 1, and an odd degree, that's what our end behavior looks like. All right, so we go here. Now I can kind of just sketch this out here. We've got just like that. All right, obviously it's not perfect, but it'll be good enough. Basically, you need to make sure that you get the bounce point and it goes through the roots and that it's going through the y-intercept. Now, of course, we can kind of check this. If you have a graphing calculator, you can check it. X plus 4 squared and then x minus 1. All right, and let's see. We can see, right? We're supposed to go through -16, which we did. We're supposed to go through 1. And we're supposed to have a bounce point at -4. So we did an awesome job there. All right, next one. So first, let's go ahead and find our roots. So here we're going to have a root of -5. And notice how I go and put these in as I find them. Here we're going to have a root at -3. And that's going to have a multiplicity of 2. So we're going to bounce at -3. All right, then we're going to have a root at -1, and we're going to have a root at +1. All right, to find my y-intercept, I'm going to go plug in 0, so I get 0 plus 5 times 0 plus 3 squared times 0 plus 1 times 0 minus 1. So we get what? 5 times 9 times 1 times -1. Obviously, you could just plug that in your calculator. I don't know why I put a 7 there. So we should get -40. So our y-intercept is going to be 0, -40. So keep that in mind. And then, let's see. We've got 1, 2, 3, 4, 5. So this is also an odd degree. And a leading coefficient of 1. So it's going to be odd and positive, which again tells us we don't know what's going to happen inside, but it's going to have the end behavior looking like this. All right. So let's go ahead and draw our graph in. We're going to go through -5. We have to bounce here. Or, oh, whoops, my bad. Sorry. We have to bounce here at 3. All right. And then we need to go through 1. Have our y-intercept, or I should say go through -1, and then we go through +1. All right, so our graph is going to look something like that. All right, do we know how high these like little humps go? No, we really don't. That's okay though. As long as you're getting the roots in there, you're good to go. You need your roots and your y-intercept and then bounce points. And again, we'll go ahead and kind of check this on Desmos. Oops. All right. So our graph looks pretty darn good, right? Oh, well, that's embarrassing. I hope you guys caught my error. This is why you should probably use a calculator. 9 times 5 is not 40. It's 45. Oops. So I could go fix it real quick. It's got to go right here. Oops-a-daisy. And then we bounce. We go back down. All right. So hopefully y'all caught that error. Oopsies. It happens. All right, so obviously we go through negative 45. We go through negative 5 here. We got a bounce point at 3. We go through negative 1, and we go through 1. And all of the stuff we predicted, other than my error, by plugging into the, by finding the roots from the graph, finding the multiplicities, determining if it's going to be even or odd, positive or negative, and the y-intercept. All right, so there's a lot of things you got to figure out to graph.